Welcome learners. In our lesson today we look at sulfur and its compounds. Subtopic is sulfur 4 oxide gas. I begin by laboratory preparation of sulfur 4 oxide. Reagents used: A. Sodium sulfite and dilute hydrochloric acid. Equation: sodium sulfite plus hydrochloric acid arrow sodium chloride plus sulfur 4 oxide plus water. Balance the equation, place 2 where there is hydrochloric acid. Now the observation made during the reaction here is effervescence occurs. Reason: due to production of sulfur 4 oxide gas. Reagent number 2 used to prepare sulfur 4 oxide is copper tannins and concentrated sulfuric 6 acid. Equation: copper plus sulfuric 6 acid arrow copper sulfate plus sulfur 4 oxide plus water. Now observation made during the reaction is a blue solution is formed, brown copper dissolves in the acid, bubbles of a colorless gas is seen. Reason: concentrated sulfuric 6 acid oxidizes copper to copper sulfate while self reduced to sulfur 4 oxide and water. Now collection of sulfur 4 oxide gas. Now sulfur 4 oxide is passed through concentrated sulfuric acid and then collected by downward delivery because it is denser than air. Now the diagram below shows laboratory preparation of sulfur 4 oxide. So as I mentioned earlier, I said you can either use dilute HCl and sodium sulfite. If that is the case, you place here sodium sulfite and you place here dilute hydrochloric acid. Then if you are using copper and sulfuric acid, you place copper tannins here, you place here concentrated sulfuric 6 acid. So in my case here, I place here sodium sulfite and I place here dilute hydrochloric acid. The reagents, so I said last time, when you are using dropping funnel should not be dipped in solution. Dropping funnel is one which has a tap. If you are using a digital funnel, the solution should be the funnel should be dipped in the solution. Now once this gas is prepared in the generator, it is passed through concentrated sulfuric acid where its role is to dry sulfur 4 oxide, then collected by downward delivery because it is denser than air. Now chemical properties of sulfur 4 oxide gas include: 1. Reaction with water. Sulfur 4 oxide dissolves in water to form sulfuric 4 acid. Equation: sulfur 4 oxide plus water arrow sulfuric 4 acid. Number 2 is bleaching action of sulfur 4 oxide. Now sulfur 4 oxide bleaches colored matter or dyes in the presence of moisture. The reason is because sulfur 4 oxide reacts with water to form sulfuric 4 acid, which reduces the dye, that is, removes oxygen of the dye, and self-oxidized to sulfuric 6 acid. Equation as follows: sulfur 4 oxide plus water, sulfuric 4 acid. Sulfuric 4 acid plus dye, which is either colored, that is arrow, sulfuric 6 acid plus dye minus O. Now the properties of the bleaching action of sulfur 4 oxide is: 1. It is temporary. The reason why it's temporary is in the presence of sunlight, the oxygen removed during bleaching is restored. 2. It bleaches by reduction. Number 3, effect on litmus paper. You look at situations, effect on dry litmus paper. Now, sulfur 4 oxide has no effect on dry litmus paper. A reason: due to absence of water to form sulfuric 4 acid. Wet blue, when lowered to a gas of sulfur 4 oxide, changes to red and finally to white. Reason is the sulfur 4 oxide gas reacts to water in the litmus paper to form sulfuric 6 acid. The presence of hydrogen ions changes blue litmus paper red. The sulfite ion in the acid reduces the dye, the litmus paper, to white. Next is reaction with the burning magnesium. Now equation for the reaction is magnesium plus sulfur foxide, arrow magnesium oxide plus sulfur. Now, observation made when a burning magnesium is lowered in a gas jar of sulfur foxide. 1. Magnesium continues to burn. 2. A white powder is formed. 3. A yellow solid is formed on the sides of the gas jar. Now, reason for the observation: the heat produced by the burning sulfur decomposes sulfur foxide to sulfur and oxygen. Oxygen gas produced. Now, oxidizing property of sulfur foxide. And this example is reaction in hydrogen sulfide gas. Equation: sulfur foxide plus hydrogen sulfide, arrow sulfur plus water. Balance the equation: place 2 where there is water, 2 where there is hydrogen sulfide, and 3 where there is sulfur. Now, observation made when a gas jar of sulfur foxide is inverted over a gas jar of hydrogen sulfide gas. A yellow solid is deposited on the sides of the gas jar. Reason: sulfur foxide oxidizes hydrogen sulfide gas to sulfur and water, while itself reduced to sulfur. The reducing property of sulfur foxide. We have the first example is reaction with acidified potassium manganese 7. The only question is sulfur foxide plus 2 manganese ion plus 2 water, arrow plus hydrogen ion, arrow 5 sulfate ion plus manganese 2 ion plus 5 hydrogen ions. Now, observation made when sulfur foxide is bubbled through acidified potassium manganese 7. Purple color of potassium manganese 7 changes to colors, or you can say potassium manganese 7 solution is decolorized. Reason: in solution, sulfur foxide gas reduces purple manganese 7 ion to colorless manganese 2 ion, while itself oxidized to sulfuric acid. Now, example 2 is reaction with acidified potassium chromate 6. Now, ion equation is 3 sulfur foxide plus chromate 6 ion plus 2 hydrogen ion, arrow 3 sulfate ion plus 2 chromium ion plus water. Now, observation made when sulfur foxide is bubbled through acidified potassium chromate 6 is orange potassium chromate 6 changes to green. Reason: in solution, sulfur foxide gas reduces orange chromate 6 ion to chromium 3 ion, which is green. Now, next is reaction with concentrated nitric 5 acid. Equation is nitric 5 acid plus sulfur foxide, arrow nitrogen foxide gas plus sulfuric acid. Balance the equation: place 2 where there is nitric acid and place 2 where there is nitrogen foxide gas. Now, observation made when concentrated nitric 5 acid is added to a test tube containing sulfur foxide gas. Now, brown fumes of nitrogen foxide gas are given off. Reason: a solution of sulfur foxides, i.e. sulfuric 4 acids, reduces nitric 5 acids to brown nitrogen foxide gas, while itself oxidized to sulfuric 6 acid. Next is reaction with acidified reaction with warm ion 3 sulfate. Ion equation is 2 ion 3 ions plus 2 water plus sulfur foxide gas, arrow 2 ion 2 ions plus sulfate ions plus 4 hydrogen ions. Now, observation made when sulfur foxide gas is bubbled through ion 3 sulfate solution. Yellow color of ion 3 sulfate changes to pale green. Reason: in solution, sulfur 4 oxide reduces iron 3 ions to iron 2 ions, which is a pale green solution. Next is reaction with acidified bromine water. Equation is bromine plus 2 water plus sulfur oxide plus hydrogen ion, arrow 2 hydrogen bromide plus sulfate ion plus 4 hydrogen ions. Now, observation made when sulfur oxide gas is bubbled through acidified bromine water. Yellow bromine water changes to colors. Reason is in solution, sulfur oxide gas reduces bromine water to hydrobromic acid while itself oxidized to sulfuric 6 acid. Now, reaction with hydrogen peroxide. Equation is hydrogen peroxide plus sulfur oxide plus water, arrow 2 water plus sulfate plus 2 hydrogen ion. Now, observation made when sulfur oxide is bubbled through hydrogen peroxide followed by addition of 2-3 drops of acidified barium chloride. White precipitate is formed. A solution of sulfur oxide, i.e. sulfuric acid, reduces hydrogen peroxide to water while itself oxidized to sulfuric 6 acid, which formation of white precipitate when barium chloride is added confirm the presence of sulfate ions.